got a plan. We're going to be doing assembly day 4, where we're going to learn how to convert a number into a string and then print it out. Today we're going to be doing assembly. Ashford, what's happening? Okay, so the plan is assembly day 4. That's going to be the main topic. Assembly day 4. We'll be doing number to string conversion, which sounds like it's super easy. It seems like it should be really straightforward, but it is not. Not straightforward when it comes to assembly, because why would you even want to ever convert a number into a string, especially in assembly, so you can print it out, so you can see where you are, and you can print it as a string onto like standard output. The architecture we're working on, this is ARM 64. This is ARM 64. So ARM 64 architecture. Yeah, for assembly code. Over the weekend, I did some preparation, and we got this file, which is a number to string. And so we know that text is the start of the code section. We're defining a function, or a global, essentially, which is underscore U64 to string. And then we're defining the start of that function with a label here. It takes an input, one at the register 0, which is the value, and then X as the first buffer. It's a buffer. And then a buffer size. Oh, interesting. Okay. So we got a buffer size. The output is going to overwrite the value in X0, and the start pointer of the digits, and then X will be the length. X1 will be the length. So the input is going to be these registers here. So 3 registers as input. So it's 3 parameters. And then the output is going to be 2 parameters. So it's going to overwrite the input, which is kind of an interesting pattern. Like, see, it says clobbers. Thing to remember this right here is kind of scary, because see, we're also clobbering X29 and X30, 3 and 4. So there's a lot of clobbering happening here, right? There's a lot of registers that we're overwriting. So we learned in previous stream that STP was to pointers, right? We're going to store a pointer. Add, which I do believe literally just adds the numbers together and then puts it into the register. So what does this say? X3 equals the end pointer, one last pointer, one past the last. Interesting. Okay. And then, so there's things happening here. I don't know why they're doing this. I don't know why. I really don't. It doesn't make any sense to me. Biswajit is, what is this code is going to do? Okay. Like, what is the problem statement that we're solving? All right. So the problem statement here is we are going to, let's go here. Let's go. Here. Let's open up this file here. And part 2 is to convert an integer or a number into a string. And that you need to do it that way because you can't print it otherwise, because it's currently represented in binary. Like, the number is a binary, and unless you convert it to essentially ASCII or a printable character, it won't know what symbol to print. Otherwise, you're just printing binary, which is hard. You could totally do that. You could print out the binary just fine, but it would be difficult for humans. Why we need to convert this number into a string. And so we're walking through some code that I got prepared over the weekend that I did some copy and pasting on the internet, and we're walking through how it works. I did optimize it a little bit to be short as possible and clean and easier to read. And it is easy to read, but I don't know what's going on. Like, what is this right here? What is this directive? What is CBNZ? What is that? What is CBNZ? I believe it's just hex, right? So this is a hex number. If value is not equal to 0, go convert. That's what I want to do. I want to change the labels to more readable names. That makes sense. Names starting with a number are undefined or weird edge case. Some assemblers won't even assemble it. Okay. So yeah, that's what we're seeing here, right? See, these labels right here are numbers. They're numbers. Convert loop here. And but the label, it just proceeds down forward, and they're jump points. So they're jump points. So if I convert that back, names like loop 1, exit 2, or loop break are usually recommended. I think that sounds like a lot better. It sounds a lot better to me, you guys. So there's the B, but it looks like my guess is these aren't even used, like 1 and 0. They're not even used. Why are these even here? Do we even need these? They're never called on. I never see these called. Like, these are never called. So can't we just comment these out? Like, they're never used, right? So I should be able to build those. Oh, look at that. This is where the C branch, B, the B. This is what's going on. This is what that is. Look from earlier. Check this out. This right here. Here you guys go. Look at this right here. C is like a conditional branch. That's what that is right there. A conditional branch right here. That's what that is. Oh, see, we're learning along the way, you guys, just by making some changes to some of the code, building and it breaks, and we're like, why did that break? Because that right there, it broke because of this. Look, and then I bet you there's another one. It is right here. There's another one. It goes back to 0. All right, so that means that we do need these, right? We do need these here. Isn't that cool? I love it. That's awesome. Branch if register is not equal to 0. Shimon, we figured it out. You totally validated us. Thank you. Yep, we figured it out. Conditional branch. You got it right there. That's it. But I don't get how value if not equal to 0. I don't get that. So what is x4 in this case? x4 is x0, which is a remaining value. Oh, okay, so this is the remaining value. Okay, I see what we're doing. So we're taking a number and say it's a number like 1,000, right? Say it's a number 1,000. So we'll do it like this. So it's like a number 1,000, like that. And then what we're doing is we're slowly stripping away at it like this until we get to the final number. And we need to do this because we need to see what each digit is in this section, right? So what is all the digits here? What are the digits here? Digits. We need to see what the digits are in each of the last position, so that way we can convert it, each of the digits, because it's 8, right? We need to convert it into a string. We need to know what that exact digit is. And that's what that is. That's where we're converting it. That's essentially the idea. That's what's happening here. Isn't that crazy? I think it feels like it's a wasteful compute, right? Converting a number into a string is a lot of work. That's crazy. Hey, Munir. Hey, Munir, good to see you. Maunir, happy you said hi. Thank you for welcoming to the stream. NZ means not 0. Wait. Oh, it does. Really? Is that what NZ means? Okay, so you've got this NZ right here. At this segment right here where you can't really see because of the assemblies on the screen there. Here we go. So right here, yeah. So this right here. The NZ means not 0. We're learning every day. What an weird operation. Like this right here, this directive. Weird. It's like such a weird, but it must be a common case where you need to do that. Case branch, conditional branch, where not 0. Then if this register is not 0, go to F1. We're learning. UDiv, I believe, is going to be, this sounds like division, doesn't it? It sounds like division. Sort of 7, divide the value. Okay, so 7 is going to be where we're storing the data. So we're storing the data here in 7. And then the value divided by 10. And so 6 is 10. Oh, check it out, you guys. Okay, so 6 is 10. So we've made the number 6 is going to be 10. So U means unsigned. Division means divide. So we're going to divide an unsigned number. 7 is going to equal 4 divided by 6. 6 is 10, and 4 is our value, our current value. And our current value is, let's see what that is. If it's not 0, then it jumps. But it's going to be doing some other math up here. Okay, so subtract 1. Okay, so 3 and 3. Okay, 3 is going to equal 3 subtracted 1. We can read assembly, you guys. I feel like we just got to the Matrix moment. I feel like I just got into the Matrix. Like, I don't even see the code anymore. I can read it now. I can see through it. It happened. It's clicking, you guys. It's clicking. This is so satisfying. To say 5 is going to equal 0 in a quote. Oh, wait, is that a string? Are these literals? Can you do that? There's considerations when it comes to that. We want to be as safe as possible with the language that we're choosing to speak out loud. But you got it. You did it right. I could tell you, but there are consequences. I really want to tell you because it's a really cool use case. But it's also a concerning use case to a lot of people. I didn't know you could do this. Is this a string literal? So you can literally say 0 as a string like this. So it really looks like that. So I'm saying W5, which is going to be an ASCII character for the, low 32 bits, is going to be like the number 0. But literally the string equivalent of 0. Is that what this is? I'm pretty sure. And then we're going to say stir B, which I don't know what that is, 5, and then x3. Okay. So see, now we're not able to read that. I don't know what this is. I don't know what that is. But I do know this. We're going to say x0 is going to be equal to x3. Start pointer, and then move x1 is going to be 1, the length, and then jump to